Good day, everyone. We are from Group C and we are here to present our project, which is AI powered air quality prediction system for Melaka. This is our group member, which is myself, Darshna, daughter of A. Kumaran. I'm the project manager, and the second member is Sofia Amira, which is secretary, and Muhammad Ijaz Ahmad, who is treasurer, and Muhammad Al Iqbal, who is the marketing person, and Muhammad Muiz is marketing too. Air pollution has become a serious issue in urban areas like Melaka, mainly due to rapid development and increasing of traffic. Pollution such as monoxide, nitrogen dioxide, and nitrogen oxide can affect both public health and the environment. Currently, most air quality monitoring system only shows the past data and cannot predict the future condition. Because of this limitation, our project used an LSTM model, which is long short term memory, which is a type of deep learning to predict future CO level based on pollution trend. By applying AI, this system can help provide early warning and support better decision making for environment management. Now I will explain the project objective. The first objective is to develop an AI-based air quality prediction system using the LSTM, which is long short-term memory model. The second objective is to predict future carbon monoxide level based on NO and NOx data. The next is to analyze historical air quality data from Melaka to identify pollution trend. And the next is to improve early warning capability for air pollution monitoring. And the last is to support better environmental decision making using predictive insight. Okay, in this slide, I will explain about tools and technologies we use. So, the programming language we use to develop our project is Python, and machine learning we use the machine learning model we use is long short term memory, which is LSTM, and libraries and frameworks we use is TensorFlow, Keras, NumPy, and Pandas and Skitlearn. Development environment is Jupyter Notebook. Web development we use is Flask for prediction interface, and visualization and interface we use HTML and CSS.
Assalamualaikum Doctor. My name is Sofia Amira and now I'm gonna explain on the project management approach. So here we have five phases. The first one is initiating where we identify the air pollution problem in Melaka and then we define project objectives, scopes and stakeholders. And the second phase is planning where we develop work breakdown structure and plan dataset usage, model selection and schedule. The third phase is executing. So in executing, we do data collection, pre-processing, and feature engineering. Also LSTM model development and training for air quality prediction. And the next phase is monitoring, where we track project progress and milestone. And then we monitor model performance and prediction accuracy. And the last one is closing phase, where we finalize system evaluation and validation and document the submission and project presentation. Okay, so this is our project timeline. We start from week 1 until week 14. So in the first phase, which is planning and requirement, that took week 1 and week 2. So in week 1, we focus on project planning, including defining objectives and scope. And in week 2, requirement analysis was conducted to identify system needs and project constraints. So in phase 2, which is data preparation, from week 3 until week 5, we carry out the data collection and data pre-processing. This phase was important to ensure the dataset is clean, relevant, and suitable for the model development. For phase 3, which is model development and training, started from week 6 until week 9. So model development was done in week 6 and week 7, followed by model training from week 8 to week 9. So during this stage, we focus on improving model performance through training and tuning. Phase 4, which is evaluation and system design, started from week 10 until week 11. In week 10, our model evaluation was conducted to assess performance. Then in week 11, the system design was planned to integrate the model into the overall system. Phase 5, system development and testing, started from week 12 until week 13. System development took place in week 13 and 13, followed by testing and validation to ensure the system works correctly and meets the requirements. And 4, The final phase, which is deployment and documentation, for week 14. Deployment and documentation were completed to finalize the project. Okay, so for planning phase, the objective is to establish a structured project plan to ensure the successful development of an AI-powered air quality prediction system for Melaka. And the expected outcomes are a clear project roadmap that guide execution, optimize team coordination, and minimize risk. And these are the control actions. The first one is define project scope, focusing on AI-based air quality prediction. The next one is to develop a work breakdown structure and then to plan project schedule and milestone across week 1 to week 14. And then to assign roles and responsibilities among the team members, select the LSTM model suitable for time series air quality prediction, to define evaluation metrics for model performance, and to identify potential project risks and mitigation strategy.
So for the project execution, there are two things, which one is automated deployment and the second one is execution flow. So for the automated deployment, we have one-click setup and also server launch. One-click setup is an automatically create a Python virtual environment and install all dependency such as TensorFlow, Flask, and NumPy. And server launch, we initialize the script for the Flask web server using on localhost 5000. Then execution flow have four steps. Step one is user input that interact with the web UI to input air pollutant parameters. And the second one is data pre-processing that data is normalized to match the model's training scale. And the step three is AI inference. The request is processed by the LSTM network, and the model predicts the carbon monoxide concentration for the next period. And then step four is the output. The result is inverse scale and displayed alongside the chatbot assistance. For the monitoring and controlling aspect, we focused on ensuring the system is both reliable and also understandable. To control the quality of our data, we implemented strict input validation at the server level. The system automatically filters out invalid or empty inputs before they reach the model, ensuring technically accurate predictions every time. We also built in robust error handling. If any calculation fails or an unexpected value occurs, the application is designed to catch this exception gracefully without crashing, maintaining high system availability. Finally, for the user side monitoring, we integrated as an intelligent chatbot assistant. This doesn't just show numbers, it helps user interpret them, whether explaining what a high NO2 level means or assessing health risks. The system empowers users to actually understand the environment they are monitoring.
Assalamualaikum Doctor, I'm Ijaz and I'll be continuing project closing. The project is officially closed following the completion of all planned deliverables. Customer acceptance has been confirmed via the project completion form through signatures. The team has successfully sought acceptance of the completed air quality prediction system from all relevant stakeholders. Goal achievement verification. The project successfully forecasted air quality prediction. All functionalities, including data cleaning and Flask web deployment, were completed within the allocated timeframe and at a zero financial cost using open source tools. Handover of the functional Flask web application and the train time series prediction model. For the lessons learned summary, the team successfully resolved library compatibility issue and model deserialization issues through discipline debugging and environment management. Final testing confirmed that the system output is correct and functions without runtime errors. Key lessons were consolidated regarding the importance of proper data scaling and the integration of AI models with web interfaces.
Assalamualaikum, Doctor. So my name is Iqbal, and I will show you the technical implementation of our air quality AI project. So we started with data pre-processing, which is crucial for handling time series data effectively. As you can see in the code snippet here, first we loaded our raw air quality data set using the pandas library, and then one key challenge was that the date and the time were in separate columns with non-standard formatting. So we cleaned this by converting the time format and then merging the date and the time columns into a single unified date time object. Finally, we set this new date time column as our index. This step is essential because it allows our models to understand the chronological order of the data, which is vital for accurate pollution forecasting. Next, we move on the feature selection. Our goal is to predict carbon monoxide levels, so we needed to know which other pollutants influence is it at the most. So we perform the correlation analysis, and the results are visualized in this horizontal bar chart. So the bar chart extending to the right shows how a strong positive correlation. As you can see that nitrogen dioxide and nitrogen oxides have the highest correlation with our target, which is carbon monoxide. So this makes sense scientifically, as these pollutants often come from the same combustion sources like vehicle exhaust. So based on this data, we selected NO2 and NOx as the primary input features for training our AI models, ensuring we focus on the most relevant signals. Finally, we evaluated three different algorithms to find the best model for our system. We compared linear regression, random forest, and LSTM networks. So we compare them using two metrics, which is MSE, mean square error, and MAE, mean absolute error. So for MSE is we want to see the which punishes larger errors more heavily, and for MAE is to give us the average error magnitude. So as we can see at the chart, linear regression, the first bar, had the highest error rates, indicating it was too simple for this complex data. So we moved to the random forest, which performed better but still fell short. And for LSTM, the bottom bar, significantly outperformed the others, achieving the lowest MSE of 1596 and MAE of 16.05. So, because LSTM is a type of recurrent neural network designed specifically for sequence prediction, it was able to capture the time-dependent patterns in air quality much better than the traditional models. Therefore, we selected LSTM as the core engine for our AI application. So let's continue on on the demonstration. So as you can see here, there's a lot of files, and if for the first time user, they have to run the setup new user, so it will automatically run all the necessary things that you need to download, with it's like pip install, and it will auto run everything and install the all the requirements that you need. So after that, after you have done that, it will automatically open the website as well, the server and the website as well. So if the user is the second time, like or more, they just have to run the run underscore app, which is I already done the setup, so I just have to run the run underscore app. Don't worry for the setup for new user. It will take a little bit long, like this as well. But for the run underscore app is not as long as this for the new user. So as you can see, it will automatically run all the commands that you need to open the backend and front end server. So as you can see here, we already got the link. So just control left click and it will automatically open this website. As you can see here, this is our home page, and we also have a chatbot. You can ask anything here, but it is limited to all the things here. You can ask a different thing, but you will have to see like if the question is regarding the CO or health risk. If other than that, then it's too much for the chatbot. So let's predict. So this is the second page for the prediction. So for example, we put in NO2 as 10.5, NO2 max is 50.2, and NOx is 15, and max is 108. So it will automatically predict. So for example here, we can predict that the CO level is negative 18.42 milligram. That's all from me. Thank you.
For the conclusion, there are three things that we have developed. First of all, an AI solution. An AI-powered system designed to forecast air quality or carbon dioxide levels for the Melaka region. And secondly, we produce a predictive model, develop and train a long short-term memory model for accurate time series analysis. And thirdly, we develop an interface, deploy the model through a functional Flash web application for real-time user interaction. So what we achieve? We achieve, first of all, predictive goal. We successfully predicted the carbon dioxide, nitrogen dioxide as input variables and accuracy and stability. The model demonstrated reasonable accuracy using clean historical data and achieved total system stability without runtime errors. A fully functional, user-friendly tool that provides accessible air quality insights for our stakeholders.
Okay, for the Q&A section, why did you choose the LSTM model instead of a traditional machine learning model? Okay, to answer this question, LSTM was chosen because air quality data is time series data that depend on past value. Unlike traditional machine learning model, LSTM can remember long-term pattern and trend over time, which make it more suitable for predicting further CO level accurately. That's all. Thank you.